Hello everyone, and welcome back to Vienna at Danaher One Center. My name is Elena Tavkin, and I'm a field application specialist from Beckman Coulter. Today I will show you how a small instrument like Biomek i5 can become your best friend in handling long and tedious methods like twist target enrichment. We will go through the main features of the Biomek i5 instrument with a SPAN8 pipetting head. We will also see how you can use its main advantages in your workflows. We will also learn then how to set up a small method with a SPAN8 pipetting head. Then I will show you how you can use this instrument to set up a twist method, starting from the library preparation up to target enrichment that can save you up to 2 days of manual work. Lastly, we will go through the Q&A session and we will see the most common questions about the Biomek i5 instrument as well as operating the twist method. So, let's begin. Now let's take a look at our Biomek i5 instrument with the SPAN8 Liquid Handling head. This is our smaller robot from the i-series robots, and it is capable of accommodate up to 25 positions of the labware. This instrument can be built whether within enclosure or without it, as well as with an optional HEPA filter. The enclosure offers you a door at the very front, which can be closed whenever you're running a method, and it also offers a so-called light curtain that stops the device whenever you cross it over here. Like I mentioned, this is a smaller device capable of positioning 25 positions. However, it can be extended to the outside. Just like in this particular instrument, we have several integrations from left side with one device and several more devices on the right side. It also has an option for more devices from the back side. Now let's take a look a little bit deeper. Inside, we have an additional instrument integrated directly on deck. And one of the key features of this instrument is its SPAN8 head. It is capable of pipetting a very wide range of volumes, starting from half of a microliter up to 5 milliliters, depending on the instrument configuration. This is a liquid-based instrument, means that volume transfer is done based on the liquid movement within the system. Additionally, we have a 360 degrees rotating gripper attached to the SPAN8 head, and it has bound geometry which allows you to reach far-reaching positions and reach, pick and move different kinds of labware throughout the whole deck on a very crowded deck place. Now I will demonstrate you how to write a simple method in a Biomek software utilizing the key features of the SPAN8 liquid handling head. We will then advance into a more sophisticated data-driven transfers. So, we are starting with clicking the button to start a new method, and the first step that we need to do is to populate the deck with the required labware. First of all, I need to select my source plate, and I can filter all of the labware here. In my case, these are going to be the titer plates. I will now choose an Eppendorf plate, which I will just click and drag directly on the deck. I will then click twice to give it a name, which will be quite intuitive. I will call it source, and let's say I will start with 100 microliters volume in each well. Then I will also do the same to populate deck with my destination plate. I will click twice, I will give it a name, and since this will be an empty plate, I know that I need to have 0 microliters volume in every well. Once I've done this, now I need to add tips. I will filter all of the labware according to the tip boxes, and I will select the green tips with a 190 microliters capacity. I will also pull them on deck. And this is how I have set up the starting step of my small method. Next, what I need to do is to configure the transfer step. I will go into the ribbon called Liquid Handling Steps, and I will click on the transfer step here. I need to start with selecting the tips, which is done clicking on my deck view here, which in any case is already pre-populated according to the available tips on the deck. Second step, what I need to do is click on my source and click on my destination plate. This populates automatically my source and destination. On the right side, the software already pre-fills the type of the plate, the name of the plate, as well as the liquid content inside. To make it a little bit more simple, I will in this case choose on automatically offer technique according to the features that I have selected for my source plate, and I will do exactly the same in the destination plate. I will select a pre-offered technique, and I will type in the 10 microliters transfer volume. Let me quickly comment about the technique. Technique is a way of transferring the liquid. It includes such aspects like aspirating or dispensing speed, blowout volume, tip touch, yes or no, and so on and so on. The last part of this transfer step is here at the very bottom, where in this quite simple method we will simply say that we want the transfers to be done whenever we are done with the destinations. Here we have pre-selected full source plate and full destination plate. Let's say we have a wish to transfer only some wells from the source into some wells of the destination plate. I will click twice on my source plate, and here, holding a control button, I will select several wells which I want to transfer from. Let's scatter them across the plate to make it a little bit more complicated, and I will do exactly the same on the destination plate. 1, 2, 3, and 5 selected wells. Once I'm done, I click on the finish step for the software to validate this method to make sure that there are no logical errors. And now, once there are no error lines indicating that there is some error made, I can now start the method. To start the method, I will click on the green arrow, where Biomek software shows me where I need to place the labware. At the very back, I will place the requested tips, and I will now place 2 Eppendorf plates in the requested positions. Once this is all set up correctly, I will click on the OK, and the method is going to start. As mentioned earlier, SPAN8 has independent channels which can move away from each other independently in the y-axis, and this is what we have just observed. If you might be questioning how software defines in which order to aspirate, well, then I can tell you that Biomek software calculates the most efficient way to, at the same time, fulfill the requested features and just to fill out the requests and the selection of the transfer step. This is how the first simplest method is done. Now, let's move to the next stage and let's look at what else SPAN8 can do. Now I will show you how to use a file to drive your liquid transfer. Let's use the same method that we have just created. I will deactivate our first transfer step, and I will use a step called transfer from file. Here I will select available tips, and I will need to select a file that I will use. I have already arranged such a file where I typed in the name of the source plate, source well where I will transfer the liquids from, destination well, as well as different volumes for each transfer. I will now select the same file. And I need to define which column, which information is going to provide to the Biomek software. I will first of all start with saying that I have a header row, and now I need to select and say that my file specifies source position in the column called source plate, and in the file I will find information about my source well in the column which I have called source well. I will also define that my destination position is actually not even selected. That's why I remove a tick here. But my file contains destination well information, which I will select from the drop-down menu, and that is called in my file destination well. I'll go down into the list, and the next information that I have provided in my file is the volume information, which is called transfer volume, and I say that I'm going to skip all of the 0 volumes. In the source section, I need to click on my source well, where I will also pre-select an automatically offer technique. And in my next step, I will also now click on the destination well, on the destination plate, where I will also click on the automatically offered pipetting technique. Once this is done, I click on the finish step. I see that there are no errors, and now I can start the method. A great feature that Biomek offers is a switch to a simulation mode. This allows you to quickly run the method and see from the very beginning what Biomek is going to execute, what exactly steps and movements is going to do, and in such way you can very quickly check your method if everything looks correctly. I can also move forward to the sides. I can also speed up the simulation and do a very quick test before start a real run with the liquids. Now I will show you another tool, a very powerful tool that Biomek software offers, that is so-called the datasets. Datasets are sets of different kinds of information that you can import into the Biomek software, and that you can use later on to drive more flexible and sophisticated decisions in your methods. Let's now continue using our created method. In the first stage, I will need to import an information into the software about the labware that I want to create the datasets for. For this, I will use a ribbon called datasets and the first step called create datasets. Here I will use a file that I have already created up front, and it contains the following information. First of all, in my column, I have source wells in order for the Biomek software to identify what information belongs to which kind of wells. I will import information that I have called sample name. This could be any kind of information. As an example, some kind of sample ID, sample identifier, and so on and so on. And the next information that I've decided to import is pick sample. That means I am going to pick only 2 out of 5 important wells based on the answer given whether yes or no in this particular column. I will now select this file. And the first view that I see here is that preview of my file, which now I'm going to use in order to say that this file is gonna contain information that I will import on my source plate. And here I need to match the fields where I will say that my identifier of the well is going to be the so-called source well. Next step, I need to make a selection of the information that I will import. Let's say I'm using again my same source well, and let's say I will select out of 3 only 2 data sets I've created. That is the pick sample and let's say the sample name. Once this is done, I can check if I have imported all of the data correctly. For this, I will use the step called View Datasets. When I click on the plate of interest, I now see a list of all of the available datasets. I can also select only one out of them. I will select big sample. That's the information that I have imported, and I can see very well that I have indeed imported information called big sample. Yes, only on the plates that I'm going to pick later on. I have also imported indeed the sample name. I can double check this, and all of the names are correct. Now, once we have done this, now let's try to transfer some liquid based on this data. Now I will again use our known transfer step. I will click source, destination well. I will transfer 10 microliters. I will also select automatically offer technique. And now what I will do next is in the source plate, I will select to use data sets that I want to base my transfer to be driven on. In this case, this is the big sample data set. I say wherever big sample data sets are equal to value, yes, please pick these wells, aspirate, and transfer into my destination well. I will also select that this transfer needs to be finished whenever I'm done with my sources. Once this is done, I can again double check with my View Dataset step how the transfer looks like afterwards. I click on my destination well this time, and I see that I have transferred indeed 10 and 10 microliters. Let me now take a look into the volumes of my destination plate, and I indeed see that I have transferred only 2 wells, because those 2 wells had the data sets called big sample as yes and yes. And this is how a datasets-driven transfer is done. Until now, I've shown you some of the features of the Biomek software as well as a simple method. Now we're going to dive into a more complicated and developed application, namely Twist method. We're going to start with opening the method, which I have already done, and we will click on the green play button to start it. First step that comes up is a user interface offering to choose one of the Twist parts. I have choice between library preparation or enrichment. We're going to start with library preparation. Once I click on the next step, it offers me more options what I would like to select now in the library preparation. I can choose any sample number between 1 and 48. Today we're going to run 8 samples. I can also choose fragmentation time. Let's say we will fragment samples for 5 minutes. Then I can choose the starting indexing position, index plate position. So what does this option mean? We can run maximum 48 samples in one run. That means if you start a 96 well plate with the indexes, you will not finish the whole plate once you are done with the method run. It means you can actually use the same plate in your next run, but then you will have your starting position not at the A1, but at much further position, at much further well, which you will be able to select here, and in such way you can reuse the same index plate in your next runs. So in our case, we'll start with an A1 well, choosing 8 wells. Next step, I will also choose number of PCR cycles from my drop-down menu. And I know that I would like to also run a post-PCR cleanup, which here is optional, but in my case, I would like to run this cleanup. And depending on my laboratory conditions like humidity and so on, I can also flexibly select the ethanol drying time in the library cleanup procedure. Now I start the method. And the very first step, what the Biomek instrument does is it flushes the system liquid to get rid of the bubbles in order to make clean and accurate liquid transfers. Once I see that the system liquid looks good, I click on the Proceed Run, and now the Biomek software shows me a so-called guided labware setup, which in a very user-friendly way shows me where exactly I need to place requested labware. I will start with coming to the category called Based Labware, and software asks me to place 2 pieces of labware, that is a magnet and a lid holder, which is an Eppendorf plate in the 96 well format, together with a arched PCR lid. I can see in much more detail here at the bottom a list of the requested labware, their positions, name of the labware, as well as the type. Not only the type, but position and the stack depth. Let's start placing the labware. The magnet goes here to this position, and the lid holder goes to the very back. Once I'm done with this section, I can click to Next. Now, software asks me to place the tips. Next, now I need to place the plate. I am placing the requested Eppendorf plate, which is going to be in the future my clean library. And here, if I click directly on the plate on the desktop, on the deck, is the type AB1127 plate. When I click Next, I come to the next section, which is called Reagents, and here I have a more extended view of each labware as well as the reagents that I need to place on the deck. In this plate, I need to place the adapters, and I see in much more detail what volumes are expected as well as what kind of reagent needs to be placed here. When I click Next, I switch to the next type of labware. This is a reservoir, which I need to place to the position P12. Sorry, not the P12. This one. Once I make a step back, I would like to show you once again that it shows you again in more detail what kind of reagent you need to place as well as the volume, and this is very well seen in the next step. As an example, the cooling block with master mixes. All of these master mixes need to be prepared manually up front, and Biomek also calculates for you, so to say, the recipe, which kind of components you need to mix, also what is going to be your total volume. It's very important to know for you that these volumes already include the dead volumes calculated for this particular number of samples that you are about to run. In the previous steps, I have not mentioned to you several of special ALPs, of special devices that need to be integrated on the deck. So at this moment, I have placed a blue cooling block, which is made of metal, and the material used is dedicated to cool the reagents. because here we have a cooling position. It cools the reagents at 4 degrees. That's why the block goes exactly into this position. We have a second cooling position, which is over there at the very end. And it has a 96 well adapter where our samples will be placed. At this very starting step, this position is also cooled at 4 degrees in order to keep the samples cool from the very beginning. Once I'm done with the last section, I click on the next. I have placed my samples, and in the final deck setup, I have an overview of all of the sections and of all of the labware. Now it is very important for me to make sure that each labware, all reagents are placed correctly. I will now draw your attention into 2 positions. For example, this position at the very corner, which has an L marking at the very top, which means that it's labware consisting of 2, and on the top we have a lid. This is exactly the same. This is also a plate which contains 2 pieces of labware. These are the adapters together with a transparent lid to cover them. Once we have checked that everything is correct, we can go to the next step, click on Finish, and the method starts. The first step that the method starts executing is distribution of the fragmentation master mix. Each tip goes into a tube of the fragmentation master mix, aspirates the reagent, and dispenses it into the samples, which are currently sitting on a cooled 96 well position. The Biomek makes also sure that reagents are mixed very well with the samples, which we now currently see in this example. And once this is done, samples will be now covered with a lid, with a metallic lid, and will be moved into a currently pre-cooled at 4 degrees automated thermocycler. This twist method is being executed until the final step of the library preparation without any additional user interventions. Now, once the post-amplification or cleanup is being done, samples are being sent to the automated thermocycler at the 4 degrees and cooled there until the user clicks on the button to take the samples out. Once the samples are being stored at 4 degrees, I can now open thermocycler by clicking this button. Once an operator is ready to pick up samples from the 4 degrees cooling, we can now proceed to an external QC. Now we have defined concentrations of our libraries in the external QC, and the next step what we need to do is fill these concentrations into a file which we will use in the next step for the pooling. I have already prepared such an input file in the CSV format where we have defined original concentrations of our samples, transfer volumes that we will need to pool, as well as a destination well. So out of our 8 libraries that we have prepared, we will now create 1 pool in a 1 well. Usually, our customers start their library preparation in the morning, and it lasts approximately 3 to 4 hours, afterwards followed by an external QC procedure. Usually in the afternoon is a good time to start with a target enrichment. Now we can start pooling the samples, which will then go into 16 hours overnight hybridization process. Let's begin with the second part of our twist method. In the first user interface, which you have already seen, we will select the enrichment part. And the next user interface offers me several options for the first pooling and capture. We have two options how to handle the very first step. We can start with the library pooling that will be done using a created CSV file, which I have showed you. If the pooling has been performed manually upfront, we can also select an option to start with already pooled libraries. And in such case, we can type in a number of pools which we will start. In my case, we will start with the library pooling directly on the robot. For this purpose, I will choose a file that I have just showed you. And now we can choose the next options for the hybridization and capture part. At this stage, I can choose the concentration method. I have an option to do it with the DNA purification beads. This option allows me to begin with the overnight 16 hours incubation without any additional user intervention, because all of the necessary reagents will be placed right now from the very beginning on deck. If I choose an option for the vacuum concentrator, then this procedure needs to be done externally. This means that after the pooling, you will receive a user pause, which is going to indicate that you need to take out the plate, the pools, and put them into the external vacuum concentrator. This means that after the pools are concentrated, you will need to place back the pools and then continue into the overnight hybridization. Next option that we have here is the PCR cycles, which can be chosen between 8 and 18 cycles, as well as the final post-PCR cleanup, where you can also define an ethanol drying time. Let's continue with an option of DNA purification beads. When I start placing all of the lab and reagents for the first part of the target enrichment, I need to keep in mind that because of 16 hours long incubation, I will now place only reagents that are needed for the capture part. Tomorrow, once the 16 hours overnight hybridization is done, we will again place the necessary reagents needed for the further part, because otherwise the reagents would be staying way too long on the Biomek deck. Let's begin with the first setup of the deck. At the moment, I already have plate with a lid, which we have used in the library preparation, as well as magnet plate on deck. Now, once I have placed all of the lab and reagents on deck, I will double check once again if everything is placed correctly. And let's assume I have now double checked and I have not noticed one mistake. Here, very nicely comes one tool in help from the Biomek software, which is called deck verification. There are two cameras installed in the Biomek, which help you to see whether there is anything that does not match the expected view of the placed slab or reagents. We can very nicely see in the corner that we're actually missing a PCR lid over here. I will show you several corners with the left and also with the right camera. Software very clearly indicates with the red cross that there is something missing. I will now place the lid. I will click on rechecking the deck. And now I see that the software verifies that all the labware is placed correctly. Now we can continue to the method. Libraries have been cleared, as well as reagents added to the pools accordingly, and now the hybridization reaction with an overnight 16 hours incubation can start. Pools are placed into an automated thermocycler for 16 hours incubation, and a message shows up for the user to know when the 16 hours incubation will be finished. At the moment, you can see that the remaining time is 15 hours. These 15 hours actually give you an additional time of 1 hour to start setting up a deck for the capture part, which will start tomorrow. These 16 hours will be done at the point where the deck is already done, when the first steps of the capture are already started, namely the streptavidin beads preparation, and therefore at the moment where the samples, where the pools will need to be already mixed with the streptavidin beads, exactly 16 hours will be counted. Now let's move into the Q&A session and look into the most common questions that you have sent to us about the Biomek as well as operating the Twist method. So one of the first questions that we've received sounds like this. Fragments of my final pools are too short or too long. What should I do? So first of all, you need to make sure that your input samples meet the requirements stated in the Twist protocol. If this is all met, then you might start looking into the fragmentation time. And you have a very nice option in the library preparation user interface where you can choose the timing for the fragmentation incubation. If you have already followed these recommendations and your samples still don't show correct fragment sizes, then you might look into the cleanup steps, because some of the volumes might not be optimal in your case. And in order to learn how to troubleshoot the cleanup steps, you might refer to another series of our NGS seminars, which is done by my colleague Milan. Next question that we have received from you states the following: my final concentrations are too low, what should I do? So while one might expect some differences between an automated sample preparation and the manual sample preparation, very strong reduction in concentrations, of course, can significantly affect your sample analysis. And to tackle this problem, we would recommend to first of all start looking into the cleanup steps, because they might be set up not optimally. And how to do this, you might again look into the seminar from my colleague Milan. Once the cleanup steps are being optimized and you still see lower concentrations that you would expect, we would recommend that you refer to our field application specialists from Beckman Coulter or Twist team in order to direct you where to look further. Next question is, what benefits does SPAN8 have in contrast to multi-channel 96 wellhead? Well, first of all, SPAN8 has 8 independent channels. It can not only move independently from each other in Z and Y axis, but can also aspirate and dispense different volumes independently from each other. This means that there are applications where you need to handle simultaneously different wells scattered across different plates. So these could be applications like normalization, where you need to aspirate and dispense different volumes, something like heat picking, where you need to move quickly across one or even multiple plates, as well as spooling. So in this kind of application, SPAN8 is very fast and can be the very good tool to work with these applications quickly. So in contrast, a multi-channel head, a liquid handling head, can also pipette single wells. However, since in such applications it would load one single tip, the handling would be a little bit more slow, and therefore it's much more efficient in handling very high number of samples at the same time, because it has 96 channels working simultaneously. However, it is very important to mention that both liquid handling heads are capable of running full methods up to 96 samples, and as a good example, this twist method which I have demonstrated to you can be run on both i5 using the SPAN8 liquid hand as well as multi-channel 96 wellhead. Another question is asking how or can I perform a QC procedure on deck? Yes, you can perform QC procedure on deck, and for this the method would need to be prepared or installed if it's already available in our database. Generally speaking, the writing and preparation of the methods can also be purchased together with your or from our sales representative, and there we have a scaling for different levels of the method complexity, which means that any of your laboratory needs can be programmed by our field application specialist. Next question is, can I adjust the methods on my Biomek? Yes, you can adjust your methods in the Biomek software, and generally speaking, we like and we really prefer that our customers learn how to operate Biomek software. That also includes writing methods, modifying them, and usually we also offer a basic training where you would learn how to write methods from very simple, pretty easy methods up to a little bit more complicated versions. If these are methods that you have already purchased from us, there are also options depending on the different levels of the purchase, which could also be modified according to your laboratory's need. So this was it with introducing you to the twist method with target enrichment on our Biomek i5 SPAN8 liquid handler. I hope very much that you enjoyed it and are now convinced that even long and tedious methods can become easy and fun to run on the automated systems. See you next time. Bye-bye.